Hi, this is Abhrajit, and I'll be explaining question number 1 and question number 2 in this short video. So let's first look at question number 1. So question number 1 says if y equals to y is satisfies these values, then we need to find out the values of capital Fy and small fy in respect of capital Fx and small fx. So we can see the value of the random variable y is 2 when x less than 0, 0 is 0 when x lies between 0 and 1, is minus x plus 1 when x lies between 1 and 2, and minus 1 when x greater than, sorry, this is a mistake, when x greater than 2. So what happens, we now define Fy of y. So we can see from this above diagram that if the value of y is greater than 2, then all points of the random variable lies within this bound. So capital Fy of y is 1 when y greater or equals to 2, because all the values of the random variables lies within 2. And similarly, f of y equals to 0 when y less equals to minus 1, because we can see the value of the random variables varies from minus 1 to plus 2. So if the value of y is less than minus 1, so then its distribution, then its probability is 0. So now let us look at the other points. So first we look at the point where value of y equals to 0. We see from we see that for x 0 to 1, value of y equals to 0. So that means that y is actually discontinuous at this point. So this discontinuous point, the difference should be fx0 minus fx of 1. That is pretty straightforward. Now we look at the bound where x lies between 1 to 2, so y is minus x plus 1. So gx equals to minus x plus 1 when x lies between 1 and 2, so y equals to minus x plus 1. So Fy of y equals to probability of capital Y less equals to small y equal to probability of, we put the value of y equals to minus x plus 1. So probability of minus x plus 1 less equals to y, that turns out to be equals to probability of x greater than equals to 1 minus y, that is equals to 1 minus probability of x less than 1 minus y, which is nothing but fx of 1 minus y for values of y between minus 1 to 0. Now we draw the graph of fyy. So we see that fy by minus 1 is 0. So at minus 1, the value of fy is fx of 2, as we put the value of 1 here. So this is a discontinuous point for fy. Now fy goes like this because it satisfies this fx formula, because for this range it has the distribution function minus x plus 1. So when y equals to 0, we see that at this point the value is fx of 1, and at this point the value is fx of 0. This is the discontinuous point for fyy. And from 0 to 2, as we see at the graph of y, from 0 to 2, this is actually a constant point for y. So the value of fy doesn't rise at from 0 to 2, and it remains fixed at fx of 0, and then at 2 it becomes 1. So this is again a discontinuous point. Now we find out fy of y. We take the summation over all the solutions of fxx by division of mod of g dash x. So this is equals to nothing but fx of x by mod of 1 at x equals to 1 minus y, which turns out to be fx of 1 minus y. So fy is nothing but this impulse function at minus 1, 0 and 2, and fyy lies between minus 1 to 0, like this. So yeah, that's it for question number 1.